Hello, it's Peter again. This video is a continuation from a previous demonstration where I talked about configuring the Ethernet ports on your EPSON controller. Again, resources can be found on the Blackboard side, course documents, a folder for EPSON robot documentation. And there are two particular documents I want to point out. There's one, the EPSON controller configuration, which is this document that talks specifically about the RSLogix 5000 or Studio 5000 configuration on the Ethernet device, Ethernet generic module configuration for input, output, and configuration settings. I'll show an example here in just a second. The other one is the field bus device, and again, you can scroll down to find the Ethernet IP slave board. And here you'll find more information on the capabilities, maximum communications for inputs and outputs, as well as then details of how you have to set up the inputs and outputs for a field bus device in the software on the EPSON controller. So I already have the EPSON controller software opened up. The same project I started earlier. I have a copy of Studio 5000 up and running. This is, again, I'm online with the PLC. I'm going to go offline here just briefly. I'm going to go down to my I/O configuration and double-click the module Ethernet for EPSON. So this is a generic module. And you can see Ethernet module, generic Ethernet. So you can completely customize, define all the settings that you want. What's important is that you match the COM format settings, which in this case was chosen the integers. That has to then match the assembly instance and the size of each range for the inputs and the size and range for the outputs, as well as the configuration. Once you have this configured correctly, and on the EPSON side, to configure the connection, I'm just going to go online. I have an Ethernet connection set up. So I'm going to connect over Ethernet to my robot controller. I'm going to go and switch to the program mode. And I'm going to go to Setup, System Configuration. And within the controller item, I'm going to click on Inputs and Outputs. And this is the field bus slave. Yeah, it's installed, yes. And you set this range, 512 to 767 for both inputs and outputs. That matches up the settings in the communications module for Ethernet field bus devices, which again is set up here. Yeah, you have to have the number of bytes being exchanged. And you obviously have to have the Ethernet IP address defined for the Ethernet IP card in order to communicate. Which you can see this matches the module settings on the PLC. So IP address matches, and then the settings match as well. Yeah, it's just it's a little different because this is 16-bit integer COM format, and this is the total range. Click Close here, and gonna click OK in my Studio 5000 project. I'm gonna go back online with my Logic Designer project because I didn't make any changes. I should just go online and reconnect me. And as you can already tell, I clicked on the controller tags here. I brought up the controller tag window. I clicked on the monitor tags window, and then tap within the controller tags window, and then scroll down to find the EPSON :C, :I, and :O. Again, the tag name is coming from the Ethernet device I defined in this module. Then we have a range of inputs and outputs. You can see a total of 16, 0 to 15. And you can see on the I input side, there is a signal coming across on the very first bit. These descriptions were added manually. They do not come in. You have to identify what these signals are on the robot side. This would be the 512 signal number from the EPSON field device. So let me just reconnect here on the programming software and bring up the I/O monitor. So within the tools, there's an I/O monitor I'm going to bring up, and you can see here on the field bus slave outputs, right? An output from the robot controller is seen as an input on the PLC side. And then vice versa, an output from the PLC, so the output data range, is seen as an input on the robot controller side. They always have to be opposites. So I can simply test this by changing this to a 1, and you can see the signal is received as an input on the robot controller side. So this is how you set up the communications. The output, this from the controller, is seen as inputs up here. And again, these are true output states. You can turn these on because they're outputs from the controller. I won't have to turn this on here. So I can double click this. That turns the bit on, and you can see it came on here, auto mode enabled. I can double click again, it turns it off. So I know I have good communications via Ethernet IP between my software controller and the EPSON physical controller to my physical PLC running in my capstone cell. So if we take a quick look at the program files, so here you can see there's a wait for switch 518 on. So this is a signal. Again, it's an input to the robot, so it will be an output, and it would be defined here as an alias tag, and you can see ready signals are exchanged, and that would go deeper into the logic. But basically all we're doing is within this program is we're going to get this project up and running, and we're going to wait here until we get a signal from the PLC that the part is in position, and then we continue on from there. This on signal 585, that communicates through the PLC logic. Okay, so these are the pick and place signals from the EPSON. There are particular tags identified that when the signal is received, be turning on something on the and other settings are set. We're going to turn on an output on the valve bank. So it gets pretty complicated. The PLC is really a translator between the EPSON robot and the signal that it turns on. Again, it doesn't turn this on directly. It turns on a signal on the valve bank via the PLC, recognizing the signal, and then changing it so that we can open and close the gripper. The other thing that's happening is, to open the gripper, we turn on the signal. When we're done, this signal 586 is seen by the PLC, and we know the EPSON completed its process, and we know we can proceed with whatever next steps are defined in the PLC program. So again, this is just one programming example. The key here is to understand how you configure and set up the system configuration on the EPSON controller so that you can communicate over Ethernet IP signals, the outputs that you need to control your PLC cell, to create the handshake between the robot controller and the PLC, to know when it's ready, when it's done, and when it should do its process. And you basically map these signals after you identified them on Ethernet, and you can create whatever you want. So this ready signal, so remote control, is another settings in the controller. This is where you say, okay, my start input signal, so those are always there. You're basically mapping it. Think of it as an alias tag. My start signal is mapped to input 512. My stop signal is mapped to input 513. If you don't have anything defined, it uses the default inputs, the hardwired inputs. Like this one here, the reset is defined to 514. These are the input signals. We can also look at the output signals. Again, these are outputs from the controller that are sent to signal 512. Again, a mapping, an alias tag of the radio signal going across Ethernet IP communications bit 512. And that is what we're seeing over on the PLC side. So again, what you're looking for is you can test this, the I/O monitor. You can select these filters to show the field bus slave, but you can see that if I just go to the inputs, the standard inputs, it's remapped to this field bus device. So again, it doesn't show up on the regular inputs anymore. But this is what we're trying to accomplish at minimum, so that we can show we have communication between the robot controller, the EPSON, and the PLC, so that we can exchange signals and send signals between the devices to make sure we can make it run in remote mode, where we don't have to manually start anything. All right, that's it for today on PLC to EPSON controller Ethernet IP communications. Thank you.